for patience, everyone. So, yeah, just running through, I guess, what we're covering today. So, red teaming specifically for the cloud. So, quick intro to CloudTrace. So, founded in 2017. We're based in Sydney. We've got an office in Johannesburg. We're an AWS Advanced partner, and we also do, thank you very much. And we also do cloud security as our speciality. So what we do is penetration testing, we do red teaming, we do incident response, managed security, and then for our SINs we do PCI DSS compliance. So thank you very much for the answer on the red teaming. So yeah, the description, if we talk about it from Wikipedia, is goal-based adversarial simulation exercise. So exactly as my friend was saying, we simulate a real-world attack. That attack can be physical, so that's entering into physical facilities. It can be digital, and it can also involve social engineering. So yeah, how to fight dirty, that's what I call it. So yeah, just a bit of background. So working from home has pretty much changed everything. So especially for red teaming. So the old days of red teaming, you'd basically get into a data center, you'd convince people to give you access into a PC. I've been in red teaming exercises where I've taken my laptop and I've plugged it into a server, and with nobody checking what I was doing, putting in a rootkit onto the device. Those days I think are pretty much gone. So a modern office environment is pretty much an internet cafe. So do you know what I mean by that? By the internet cafe? So that means that you go in there to get internet, basically. Everything is in the cloud. Any data that is of any value to a company, that's all sitting in the cloud. And attackers know this. So this is what it looks like. This is the new environment. So in the old days it was a physical perimeter, and people used to say endpoint was a perimeter. But I think cloud API authentication is a new perimeter. So all of the data that used to sit in the company's own data center, obviously now sitting in SaaS providers, cloud providers. Some of the examples, obviously the big ones are AWS, sitting in Azure, sitting in 365, Salesforce, Snowflake. So huge amount of data sitting on somebody else's computer. But the most important part of this slide is that any of that data sitting in any of those companies' environments is one API call away from being pulled. So these are the new Office keys. Do they look familiar? So does anyone know that top one? What that is? It's JWT. Tricky question on the last two. Does anyone know 1 point for what they are, and then your second bonus point for why they're different? Absolutely, well done. Do you know why they're different? So the AK is a permanent access key, and the ASI is a temporary access key, so an STS token. So why that's different is because the session token is short-lived, and the one starting with AK is a long-lived one. So if you have that token, then basically you've got full access forever until that's revoked. So all these keys that you're seeing here, this basically displaces what we used to do as red teamers, because we used to have to walk into a data center to have to pull someone's database. Now we just need one of those. That's pretty much it. Cool. So we'll jump in how to fight dirty. This is the interesting part. So this is pretty much what we do when you run a cloud-based red teaming campaign. So 4 steps really. So we revert to phishing, because that's still the easiest way to get access into an environment. We do a very targeted phishing campaign though. What we do then is we use that phishing campaign to capture session tokens. Those tokens that we saw there, that's what we're after. Not necessarily the AWS ones as a primary goal, but we'll come to that later. We use those tokens to access SaaS applications, and then we maintain persistence. So we'll run through each of these. So we'll start off. Who's run a phishing campaign before? We have to show our hands. Done phishing? Alright, great. So hopefully I'm not preaching to the converted, but pretty much this is the first step when we do a red team exercise, a cloud-based red team exercise. Because as I say, it's the easiest way to get into an environment these days. So what we do there is we actually set up a very targeted phishing campaign. So we use LinkedIn to target who we want to be, or whose cloud access we want to get. We do that by crafting up very good phishing emails. So we have a fairly high success rate of hits for our phishing emails. And what makes a good phishing email? I guess the first one is that ending up in spam, because that means that's gone, that's game over. Very important to make the email look presentable, so especially images. Nothing looks dodgier than a mail that arrives in with an image tag instead of the actual image. So we also, as I said, we do a lot of targeted campaigns. So we'll start off with LinkedIn, and we'll work out which part of the company that we're targeting, which part they actually work. So we'll look at the IT department, the HR department, look for personal assistants, because they often have a lot of good access that you don't necessarily think they would have. But they're also very easy targets to catch in a phishing campaign. So we use that extensively, and we build out a campaign list with all the different, basically, personas that we're going to target with the phishing campaign. And then we spend a lot of time trying to make the emails familiar. So we don't use out-of-the-box emails from typical tools. We actually spend a bit of time thinking about what is a good email that someone will look at, make it look believable, and actually get a very high hit rate. So we use that knowing your audience piece there. So we craft for each of the personas that we pulled from LinkedIn. We craft a very specific email based on that, and we'll jump into the details in the next few slides. So first we'll start with jumping in how we beat mail filters. So just some tips on here. So this is what Gmail does. So Gmail does AI enhanced spam filtering. It's actually really good out of the box. So I'd say probably better than, just from some of our testing, probably better than a lot of the commercial spam filters out there. They block about 10 million emails every minute, according to them. What we do, we have managed to bypass it. And how do we bypass it? So this is an example of a targeted email that we would have done. So we work on the principle of if somebody's used to seeing a certain type of email, then they'll generally click on it without thinking too heavily, especially without going into too much of the detail. So these are two different emails. One's the Google one, one's our one. Should be fairly easy to see which one is our one. You guys know which one is the Cloud Trace one? Anyone forget? One at the left or the? Yeah, so it would be fairly obvious if someone had a good look, because it comes from a security team. The domain is googlemfa.com. So anyone who did the Googles would be like, hey, that doesn't belong to Google. But the fact is it looks exactly the same, the actual content of the email. So we've crafted that very specifically to look exactly the same as the Google email. This has a very high hit rate. Now you think Google would block this, right? Because it's like, hang on, this looks exactly like an email we set up. And it's actually asking users to click on a link and enter in their password. How do we get around their spam filter? So it's a fairly old trick, but it's pretty successful. Is that when we craft up the HTML for the email, we put in HTML tags, span and div tags. We actually just call the class names anything that don't get used anyway, but it puts in a level of obfuscation for the machine learning. So we just fill it with a lot of that, and that purely on its own has the effect of confusing the machine learning to the extent that it passes it through. What we also do is we put in what looks like a normal email text, and we've got auto generators that will generate this kind of text for every single email uniquely. So we've developed some tool sets that do that for us. So that's just been put in there with a zero font size, and we've put it in the obviously at the top. So when I guess a software is reading through it, actually reads like a normal email before it hits the actual body which we've constructed below. So just those two tips alone, there's probably a few other things that we do, but just those two alone have helped us bypass Google's spam filter. As I was saying before, having a email that looks legitimate is probably most of the battle. So you've got to have the content right, but it's also got to look presentable. So the issue that traditionally we've had is mail filters blocking external URLs for displaying images. And we've also had issues with the when you're trying to embed an image in the HTML just as raw data, that often hits a spam filter. So we've developed a tool which actually creates an image based on a table. So it's 1 pixel by 1 pixel cells, and then we color that in based on the image that we're trying to represent. So in this example, that shows up perfectly in Outlook with the Microsoft logo, even though it's not a traditional image. It's actually just constructed of table cells. So this has also probably been one of the secrets to getting high click rates, is just making sure that every time we do a campaign, we put in an image so that it appears in the email, and this works regardless of what mail client they're on. And as I was saying before, one of the main criteria for a successful phishing campaign is making sure that we use familiar email content. So this is a good example of one that we use fairly frequently. So we'll work out what the quarantine software is that the company is using, and you can often just see from MX records or from other DNS records what their mail filter is. What we then do is we craft up based on we've got examples of all the different mail filter quarantine emails. Once you know what their mail filter is, we'll actually craft up a specific email to look exactly like the quarantine email message. So the reason that's successful is because people get a lot of these, right? So they're very used to clicking on a quarantine link. We do obviously generate our own. We generally generate our own domain name to make it look more realistic. But yeah, we get a very high success rate, especially when we put in a very enticing line as the subject that's been held. So for example, if we're targeting a sales team, we'll put in a notification to say you've got a quarantine email for a new sales lead, and we'll probably get about an 80% hit rate on that. So everyone will click on that, they'll open up the email, get diverted to our login screen, and then we go to the next step. Has anyone here used Evil Jinx? No one? Someone use it? So Evil Jinx is fantastic. So it's basically used to bypass MFA. What it does is it proxies requests from our phishing site. So the idea is it acts as a proxy, so that it passes through all of the two-factor authentication to the identity provider, and allows us to capture the resulting token when it comes back. So any if you think about Microsoft 365 or Workspace, we can basically present up a sign-on page through the phishing campaign that will look exactly like one of their login pages, and we can proxy the request so we get the token when it comes back. So this is an example. This one's pretty easy to spot from the URL. Which one's ours? The one on the right that says login.maliciousite.com. That's our one. So we basically duplicate exactly the sign-on screen that a user will be used to see. We make it very, very similar. So when they click on, if we use that example of the quarantine email, and the sales guy clicks on the quarantine email, he'll be presented with a page like this. He enters in his email address, he enters in his password, he gets a standard MFA prompt. That prompt is coming directly from Microsoft in this case, so proxied by EvilJinx. They'll enter in the MFA credentials, gets passed on to Microsoft. Microsoft will pass the token back, and then we capture the session token. So we've got the token, the post-MFA token. And this is what it looks like in EvilJinx when it comes back. So what we get there is the main bit there is the cookies at the bottom. So those fake and login pages obviously is what gets the user to enter those credentials. EvilJinx captures them, so we get their password. We don't get the MFA because obviously that just gets passed through to the identity provider. So I don't get the token code if they've got a token code. But yeah, we get the token. We get the token that can be imported directly into our browsers. So the important thing there is that once you've got that token, there's no MFA doesn't apply because this is post MFA. So we import it straight into our browsers. We capture the user agent string as part of this. That's fairly important because it's pretty common for a blue team to track or suspicious user agents using a token. So we always make sure we use the same token. We'll talk about the IP addresses in a bit because we also use proxies for our IP addresses when we use the session tokens. If we know that for example, a company is using Netscope, we'll use our own Netscope account so that we get a Netscope IP address. We use the same user agent, and then we basically use that to get in. You don't have to obviously change the user agent or change the IP address, but it makes it much less likely that we'll get caught. So this is the red screen of death. Has anyone in phishing seen this red screen of death? This is what we hate seeing when you're doing a phishing campaign, because it means you just burnt a domain. And we've got quite a large stock of domains, but it's very annoying when we burn one. So the red screen of death is basically Chrome or another browser saying that beware, we caught these guys doing a phishing campaign. The way it works is that Google also visits, basically every time a link is clicked in Chrome, Google also visits that link as part of safe browsing. And they've got a whole lot of algorithms that work out if the site is malicious or not, and then they share that with Safari and Firefox. So the annoying thing there is if you've got a campaign underway, you've got your links out there, as soon as it gets turned on the browser, no one's going to go past that red screen, unfortunately. So very important to avoid getting the red screen of death when you're doing a phishing campaign. So this is how we avoid it. So we obviously, as I said, we use multiple domains. We actually have quite a stockpile of domains because what we've also found is a lot of the spam filters and reputational filters will look at when the domain was registered. So if you registered, and even the CASBs like Netscope will do that as well. So if the domain has been registered recently, then it's much more likely to be caught by spam filters or by safe browsing. So we use multiple domains and then we use a unique nonce for each link. So every link that we send out has a unique string in it, which we've modified the EvilJinx code so that it actually checks that nonce when the phishing link is hit. So what happens in the process that we follow with our tooling is that when we send an email, we generate one of those nonces, we add it to Redis, so just an in-memory database, and then when we get a click on one of our phishing emails, EvilJinx, our modified EvilJinx will check that nonce, and it will say, hey, if that's valid, then it knows that it's a good link, and then we delete it from Redis. But if it's not valid, then it returns an empty response. So why this is important is because the way that safe browsing works with that red screen of death that I talked about the user will visit the site first, and then Google will visit the site afterwards. So when Google visits that exact same link, they're using the ones that the user used, and then they just get an empty response back. So as far as Google or any of the other cloud providers like the CASBs are concerned, that site is dark as soon as they click on the link. So that's helped us a huge amount avoid the red screen of death. And we tried a lot of things. We tried to block setting IP ranges, block Apple's IP range, Google's IP range, all the CASB's IP ranges, Microsoft's. But this works really well. The other thing we have to be really careful of in our phishing campaigns is making sure that as soon as we get a successful click, that we use that data straight away. Reason obviously because the sessions expire. We don't want to have crafted a good email campaign, got someone to hit the phishing link, and then we can't use their session. We don't want people staring at the Evil Jinx console all the time. So what we do is we've set up Slack. So Slack, we've got a Slack webhook. So as soon as somebody clicks on that link, there's a whole lot of celebration in our office. We get a Slack notification to say we've captured a password, we've got a session token, the Kinsey is the Microsoft token, so we get that notification straight away. So we obviously get these notifications on our phone so we can get somebody to use the token. So that's basically how we get tokens through phishing, which is obviously a very important part of it. But then we get to the fun part. What do we do when we've got those tokens? That's where we harness the power of SSO. So yeah, the great thing, and this is why I was making the point at the beginning about SSO, or about the move in the modern world to everyone using SaaS applications. It also means everyone's moved to SSO, or a lot of people have moved to SSO, and that's fantastic for red teaming. So that means as soon as you got one of those tokens from an identity provider like Microsoft or Google, then we can basically use that exact token to swap it for a SaaS token. So how do we do that? Multiple ways, but generally the easiest one is to go to the single sign-on portal, myapps.microsoft, or the equivalent for Google, the Google Apps portal, and that'll show for that user. And this, what you're seeing there, obviously not a real My Apps, but when we load those session cookies into a red teamer's browser, when we go to My Apps, we'll see every app that they've got access to with that session token. So great thing there is that then as soon as you click on one of those apps, the process that gets followed is the session token that we've used. As part of that SAML process, it will get exchanged for a new token and give you access to that application. So why that's fantastic is because there's some awesome, from a red teaming point of view, some awesome applications that you can get access to. So obviously when you're doing a red team application, you've generally got an objective, and it could be getting customer information, you're downloading code from a code repository, sensitive code, or you're pulling data from all of their data from a data warehouse. So things like Snowflake, Databricks, Amazon Redshift, Google BigQuery, those are probably the crown jewels when it comes to us getting access. People that don't know what they are, they're basically sucking data from everywhere in the company. That's the idea. So all the disparate databases that sit around, the data from those gets pulled into one of those systems. Like Snowflake, for example, could have data from hundreds of different databases, all sitting in a cloud accessible, internet accessible system. Not so much anymore because Snowflake did have an issue with people using tokens, so most people are now tying them down to IP address. But like I was saying before, you can still use the CASB to bypass that. So we get access to data warehouses, we get access to code repositories, CRMs, but we also get access obviously to mail and file hosting applications as well. So we talk about a CRM example. As an example, and Salesforce is a great one, by the way, for red teaming, because the amount of sensitive data in there sometimes surprises us when we get into a Salesforce org. Companies store a lot of sensitive data in their CRMs. So in an example I'm just running through where we send out a targeted phishing campaign. We say, for example, get a salesperson, click on the link, we get their token, even if they don't have access to or they don't have it showing up in my apps, you can just directly go to their force.com URL for their company, and then with that session token, that will basically give you access directly in. So yeah, we love Salesforce because of the data that gets stored in there. A lot of people will store in the documents, scans of driver's licenses and passports. There's a whole lot of personal information. But what we like the most is that you can dump the entire contents of every object store via the API and the CLI tool. What I'm showing at the bottom there with that screen is basically us just dumping an entire customer database. I think there we had probably about 8 million records. Probably took about 5 minutes on a good internet connection to download all of those. Salesforce very kindly has a syntax similar to SQL called SQL, and you can basically specify, like you would with a SQL query, everything you want to pull down. You'll pull down basically the entire contents based on the fields that you want to pull. So that's important because in Australia there's a lot of laws around privacy, and there's also notification. There's law to ensure that breaches are reported. So if anybody does have if anybody does have a compromise like this, like what I was showing there, where there's 8 million records downloaded from their CRM, that's a huge reputational impact for the company. So yeah, we definitely like to flag that this kind of stuff's possible so they can lock it down. I was saying before sorry, this is a duplicate of that slide. I was saying before about Microsoft 365. So if we're targeting a customer that's running on Microsoft, or they're using Entra-ID and Microsoft 365, then that's also a treasure trove for any kinds of data that might be in our objective. So just getting access to the user's mailbox, that can be super useful during a red team engagement. So the kind of data that we pull out of there is obviously customer data, because customers will email documents to salespeople, to customer service reps. People share passwords via email, so we'll craft up queries where we look for shared passwords in their emails. We very importantly look for examples that we can use in our external phishing campaign. So as I was saying before, the most successful phishing campaigns are the ones that we use where we craft up content we know someone's used to seeing. So we'll look at the kind of emails in a typical user's inbox, and a lot of them will be company emails. So they'll have like a company newsletter, for example, that'll go out, and then we'll use that template to craft up a new external phishing campaign. Because what often happens is we'll get a lower privileged user to click on one of our phishing emails, and the IT folks and those are the ones whose credentials we want, right? Because those are the ones that have all the God level access. So we want to get access to their session tokens. Those are the ones that are much more suspicious, and they know what a phishing email looks like, and they know to check for to look for the URLs, and they know what a dodgy domain looks like. So those are the people that are really hard to get to click on an email. So we'll often compromise, say, especially salespeople. No offense if there's any salespeople in this room, but the salespeople are always a lot more. If you make it sound like an email is going to get them closer to a sale, they're much more likely to click on a phishing email. So we'll typically get into the organization's account through, say, a salesperson's account. We'll look at what's in their email inbox, and we'll use that to target the other users in the organization. exactly like those quarantine emails, will look for something that's sitting in their mailbox that they're very, very used to seeing. For developers, we look at what their repo names are called, because we can often see that, and we'll mention things like new commits, or there's a PR requiring a review, and we'll send those to the developers. But we want to get the content looking good, so we use access to an existing email to get that right. The other thing that we get out of access to an inbox is links to SaaS applications that aren't in my apps. So not everything gets rolled up into an SSO portal. There's often some people that will just use the links, say in their bookmarks to get to a SaaS application. So we can find those often in the emails. We also get access through Microsoft 365 into things like SharePoint and OneDrive. If we're targeting Workspace, we'd obviously get access to their Gmail, to their Google Drive. Those often also store a whole lot of sensitive information and documents in there. The other thing that we use when we've got access into an inbox is phishing internally. But we have to be careful with that, is because that's much easier for us to get caught, is if we're using a internal email account to phish other users, but it's very successful. So if we've exhausted all other avenues for getting other users to click on our external links, and we'll generally use a lower privileged account, and then we'll phish other users internally. And that could be things like sending out, hey, here's a SharePoint link, because the internal mails won't go through the external mail filtering, so they're much easier to get out there. They come from a known person when they get sent out. So just by simply sharing a document which has a URL to our evil jinx, we can convince somebody to click on that link and then get there. Thank you, Microsoft, for this, getting that pop-up that says, hey, you need to pass single sign-on to access this document. Little do they know they're giving up our session token when they do that. So very useful to get access into a mailbox for all those reasons. So I'll just pause there for a moment. There's a few other examples that I can go through, but yeah, like I say, the entry, getting access to all these SaaS applications through SSO. This would be prior to the cloud world. If you wanted to get access to every application in the company, and you wanted to do it as part of a red teaming exercise, that could be months of work. We can use if we do a really well-crafted phishing campaign, we can compromise a good percentage of customers' applications in probably 2 weeks, including all of our recon. So super successful, because all you need is just a couple of links. You just need one of them to be a privilege, or have some level of privileges to those apps, and then those session tokens get us straight into their application. So yeah, SSO and the cloud world has helped us a lot as red teamers. So I'll just pause if there's any questions or anyone wants to ask anything on what we do when we've got those tokens. All hopefully pretty clear. So one of the objectives that we always have during the red team engagement is how do we maintain persistence? So once we've, as you can tell, we put a lot of effort into getting those credentials. We crafted really targeted campaigns with a lot of technology to make sure we don't get caught by spam filters and red stream of deaths and all those kind of things. So we put a lot of effort into getting those tokens. Those tokens obviously expire, so we need to make sure that for all that effort we won some reward. And we also do a lot of lateral traversaries in those tokens, going between other cloud service providers. So we want to make sure they can last. So we need to make sure that our access, once we've got that token, is persistent. What's the first thing we do? First thing we do is we check for MFA. So this is an example from Entra ID. So when evil jinx does the proxy of the identity request, we obviously get the password and we get the session token, but as soon as that session token expires, then we only have the password, and we obviously won't be able to bypass MFA again unless they click on that link. So what we'll often do is add our own MFA device to the account. We generally base this on, we do a lot of recon around how many security people have in the organization, because this does trigger an alarm if you turn on the default rules in Microsoft Sentinel, for example. Most SIMs have rules to detect when there's new MFA devices being added, but they are quite noisy because people do add a lot of devices. But what we do is we just check how many security people they've got. We can base that off LinkedIn. Are they likely to be looking at every single notification that comes through when your MFA device added? If they've got 1 or 2 security people, almost guaranteed no one will look at that if they've got more than 100 people in the organization. So what we'll do is we'll go in and we'll put in our own MFA device under their account. That then means when we log in again, we've got their password and we just choose our own device as the authenticator. But what would happen if the user changes their account? Because that's the other issue, right? We've added in our own device, but if the password gets changed, we don't get to the MFA prompt. So what we'll typically use is we'll look to see if they've got any kind of self-service or password resets. Obviously, there's a lot of different ways to get users to reset their own passwords, because it's quite painful for service desks to use that. So we exploit that to give ourselves persistence. And this is an example from Entra-ID. There's a service called Self-Service Password Reset SSPR. You can actually go in there and set up your self-service password. You can set up your security questions for a self-service password reset. Very few people, from my experience, actually use this in companies that we've targeted. So there's often no security questions when we go in there. So we'll go in and set up our own security questions, and then that means if they've changed their password, then we can just go back in and change those security questions, or answer those security questions to get access back in. Obviously that's quite noisy, because then the user will be locked out because we've changed their password, so we use that sparingly. But it is a way of us to keep persistence, so we generally use this for the more high privileged accounts. And this is my favorite one. And this is actually the one that we start with. So once we've got access to a SaaS application, the first thing we'll go and do is we'll go and generate either an API key or an OAuth connected app. And the reason we do that is because that gives us full unrestricted backdoor access into that SaaS application. It's very unlikely to be detected either by a SIM or by the user themselves, because I don't know how you guys are like, but I mean, I'm obviously very security conscious, but checking my own personal SaaS services for how many API keys I've got is not something I do on a regular basis. Obviously at work we do, but at home probably not as much. So, and most SaaS applications will let you set up your own API key, either that or an OAuth connected app, which effectively is the same thing. You just set up a long-lived connected app, and that gives us access at any time, even if that user's account gets revoked, even if someone realizes that, and this has happened lots to us in the past, where the security systems have detected that that we've compromised an account, and then they'll immediately reset the password. Some of them will be good enough to go and reset or revoke all switches for the blue teamers that are in the room. If you've ever got a compromised account, definitely always go in and revoke all session tokens from the identity provider. That's super important, because just by resetting the password, that doesn't automatically revoke those session tokens that we were showing there. Those wouldn't automatically get revoked. But if somebody did go through that, reset the password, reset when you revoked all of the session keys for that specific account, It's very rare that they'll go in and check the API keys and the connected apps. So I'd say there's probably, out of all the red team engagements, there's probably only been one case where somebody's found an API key that we've generated to give us backdoor access. So really, out of all the tips that I'm giving today, this is probably for maintaining persistence. This is the biggest one. So what we do once we've got that token, so I've got an example on there of generating a Salesforce token. So it's pretty simple. You can use a CLI to generate the token. I'm using a command there, which is a SFDX, which is a Salesforce developer utility. And what that's saying there is that I've been issued an access token. It doesn't expire unless somebody goes in and deletes it. That doesn't expire. So for as long as that account is active and no one has checked the list of tokens, which is a hard place to go and find in Salesforce, I've got permanent access to that Salesforce org. What can I do with that? I can do what I showed before, where you can dump basically all of the contents of Salesforce objects directly from the CLI. So as long as I've got that access token, I can do everything that they can do from the UI, but much more efficiently and much more easy to exfiltrate. So yeah, this is the first thing, as I say, we do once you've compromised a SaaS application. That was it for the intro to red teaming in the cloud. Maybe I'll finish up with saying that in terms of the changes that we've seen in security, I've been in security for 25 years. I'd say that the combination of people moving to cloud, COVID, and then the subsequent work from home has pretty much changed the way that we do our red teaming engagements now. I'd say it's made it much easier. In the past, we had to do a lot of the physical access. We had to try and get individual accounts for every single application. It was a lot harder. We can pretty much now, as I was saying before, in about 2 weeks, it's very unlikely in a red team engagement. It's very, very unlikely that we won't compromise at least one of the company's critical SaaS applications. If they're over about, I put in a caveat, if they're over about 100 people, generally the smaller the organization is, can often be a little bit harder. When they get a bit larger and they've got a sprawl of applications and users, it's very easy to at least convince one of those users to click on a phishing link and get their session token. So yeah, it's made it a lot easier for us to get access to our objective when we do a red team engagement now, which is great for red teamers, but I would say for the blue teamers in the room, it's definitely something to be aware of, because as I say, that those session tokens that I showed before, that I called the keys to the office, they look pretty innocuous on their own, but those come through in our Slack notifications. There's huge celebrations, because you got one of those and you pretty much got what would take you ages to get somebody's username and password, and then you don't have to worry about whether that MFA. As soon as you got one of those session tokens, we straight into our target application. So yeah, for the blue team, there's definitely something to be aware of. A couple of tips for the blue team is to end off with, because always, obviously, one of the purposes of our red team engagements are to brief the. Sometimes we do a full purple team, but we always, even if it was a pure red team engagement, always give tips to the blue teamers for how they could detect us. One of the main things is detecting the use of a session token from a different source. There's a lot of out-of-the-box SIM rules. If anyone's using one of the more modern SIM, Sentinel's really good for that, where you can map off all of the factors with every authentication request to check whether that token has been stolen. So obviously the normal one that people check is this from an IP address in a different country? is it from, if we're using a CASB, is it coming from our CASB, like our Netscope range, or our Zscaler range, or our zero-tier range? Is it coming from one of those? Those we can definitely bypass. I wouldn't use the IP address on its own. It should just be it should just be an early warning signal. Probably the other one of the good things is the user agent string, and that's why I was saying we always change our user agent string when we load a session token, so that it looks like the authentication requests from our browsers are coming from the targeted user's browser. But a lot of people, because we do incident response as well, so we get a lot of investigations when a cloud app has been compromised, and there's not many people that actually check the user agent against the session token, and it's quite a good check too. The things around the timing when a session token is used, that's always a really good rule to put in there. But ideally you want all of those combined. So is it coming from a different IP address? Is it coming using a different user agent? Is the session token being used from two different IP addresses or user agents at the same time? Those are all really good indicators that somebody's compromised a session token. So I would definitely include those. What I was showing here about the API keys, that's really important, because we've done a lot of incident response where we find this exact same technique used, where people are doing their backdoors using either a no-auth connected app or an API key or token that they've generated. So definitely getting a notification from all of your SaaS applications when there's a new API key or auth connected app that's been registered. That should be one of the ways to detect this kind of attack. And then the last thing, just to add on that one, when there is if you're a B teamer and you've had a compromised account, absolutely always remember to revoke those session tokens, because that's the quickest way to get somebody out. A lot of people will just change the password, but yeah, that doesn't automatically reset all of the existing tokens out there. So really important to revoke all of your session tokens. If you have a compromise, if you're in an SSO environment, you absolutely have to reset all of those or revoke all of those session tokens. And that was pretty much it on everything that I was going to run through. So, guys, thanks for any questions, if anyone wants to ask now, you can come up afterwards and ask me as well. Happy to have a chat. Does anyone have any questions? No, we do. Thanks, everyone. Thank you very much for coming.